Okay, it's 3 o'clock. I'm gonna go ahead and start the meeting. Hope you all are well. Thank you for participating. First of all, some of the status of what's happening in the working group. In August, we submitted the needs requirements verification validation lifecycle manual to Tech Ops. It's such a large document that it's taking a little bit more time to get through that process. Also in August, Raymond Wolfgang did the INCOSE monthly webinar and he introduced our products. There's a lot of questions that came up during that presentation. And so the focus of our September cafe was on those questions. And we had really good discussions. We ended up with about 4 other questions being addressed. And so we got out of 16. So we got more to talk about. One thing that we want to talk about is Yammer. All of you should have received an email from INCOSE with your INCOSE email address, and that allows you to log into Teams. And then from there, you can go to the lower left page and you can select Yammer. And then within Yammer, we have the requirement working group has its own community and you can select that. After the last cafe, one person asked some questions and we had a dialogue. What we'd like to do is for everyone in the requirement working group to go ahead and get into Yammer. We'd like to be able to have an ongoing conversation amongst working group members. So if anything comes up at work and anyone has a question about needs requirements, verification, validation, whatever, feel free to use the Yammer page to post your question, and then all the other working group members that have logged in, they'll be able to see the question and you'll be able to get a response from the community. So Yammer is something that INCOSE's really wanting to try to get a good dialogue going on. Also, besides the requirement working group, you have INCOSE Tech Ops, you have INCOSE in general, and you have other working groups. So it's a good place to be able to have a dialogue, make announcements, ask questions. So we encourage you to do that. We welcome comments on any one of our new products. You can go to the Collaboration Connect website, and under our requirement working group collaboration page, all of our products and the latest version of each of those products is in that folder. So you all have access to products as they exist today. If you do have any comments, additions, corrections, or whatever, we welcome your comments. So at this session, we're going to continue to address the questions, from the August webinar that Raymond gave that introduced our new products. There's a lot of good, thoughtful questions. Like I said, we only got through 4 of the questions last session. So we may not be able to finish addressing all the questions in this session either. I have some slides prepared for some of the questions, but we really want to make this session a dialogue amongst all of you that are attending. And so any comments you have, jump right in and questions. We also have chat, and chat is nice because it's something that's recorded. And I don't know if you all realize it, but in the bottom of the chat button on the right, there's 3 dots. And those 3 dots allow you, before we end the session, download the whole chat history to your own computer if you want that. You probably got a message on your screen that we are recording this, and we'll put a copy of this on our Connect website. The copy from last month version that we discussed the first 4 questions are there. So if you weren't able to attend last month, you can go and listen to that. Our plan now is to hold regular Exchange Cafe monthly meetings and make this a regular type thing. In addition to that, as the opportunity comes up, if someone has a presentation you want to give, some people like to use this opportunity to maybe do dry run on a presentation that they're going to give to some group or in preparation for the international symposium or something. That's fine. Just let Tammy and I know, and we can schedule a separate session for your presentations. As far as the cafe is concerned, once we get through this list of questions, then any other questions that you have, we want to discuss those. So if you send us our topics that you would like addressed in the cafes to guide our conversations, just let us know. Before we get started, does anyone have any comments or questions about the requirement working group or our status or anything? Okay, the first 4 questions that we covered last time, like I said, I'm not going to go into them now, but the discussions were really good. It took the whole hour just to get through these 4 questions. And so it was a really good exchange that we had. The next question we're going to talk about is the manual going to cover other iterative sequential life cycle approaches or be centered on the V model. And one disadvantage that I have is I'm not sure who asked the question, so I can't really ask if they wanted to elaborate on this question. When they talk about the V model, I think at IS, there was a discussion, a panel about the V model, and there's a lot of people think it's kind of outlived its usefulness. For me, what I like about the V model is it shows that in system engineering, we are decomposing the system into levels, which has happened on the left side, and then complete design. We come up with design output specifications to build the system to. It's built, and then the right side of the V is then we go bottom up, putting things together, and at each level, then there's a verification validation activity that takes place as you move up the right side of the V. Now, one of the things that the CAB was really interested in is one of the issues with the V model is that it gives the impression that system validation only occurs on the right side of the V, and that's not correct. CAB and what we have in the manual is that we do needs, requirements, design, verification, validation on the left side of the V, and by doing this continuous verification validation left side of the V, we end up with a lot less problems on the right side of the V. A lot of the goals that the CAB had set was addressing, making it more apparent that we do verification validation on the left side of the V. One of the things that unfortunately happens is the lifecycle processes that in 15288 and in the system engineering handbook, they have to be presented in some order. So they are. Some people tend to want to put those in silos and think that those activities are meant to be done serially, one after the other. And that's not the intent. In the manual, we really emphasize the need for collaboration, get rid of the silos. A lot of things are happening concurrently with the integrated, multidisciplined, collaborative project team. In that sense, we're doing a whole lot, and concurrently at the beginning, it's iterative recursive process. As we move down the left side of the V, we're developing architectural models and so on, concurrently with defining the requirements. So all that's happening. And system integration is something that we need to be thinking about the whole time, not just on the right side of the V. System validation, system verification, the same kind of thing. But one of the problems with the V model is that it kind of oversimplifies things. It doesn't really get into the nuts and bolts. So when we're moving down the levels, we have higher level requirements that constrain what we're doing at the next level down for whatever your architectural element is. The manual stresses that at each level, we're defining lifecycle concepts, we're defining needs and design input requirements. And then through the architecture process, we come up with architecture. Then we flow down those requirements to the next level and repeat the process for each piece of the architecture. In reality, what's kind of masked, and when you look at the V model on the left side, is what we're really putting together is a hierarchical view of our system. And there's concept, needs, and requirements that exist for each one of these. Now I'm using a convention that's in the system engineering handbook about, instead of talking about subsystems and all that, I'm talking about systems and system elements, where a system is some entity that's going to be further decomposed by the project team. A system element, the project team is not going to do any further decomposition. In this diagram, we have 21 different system elements that make up the overall system of interest. As we move down the architecture, we're defining lifecycle concept, needs, and requirements for each of these 21 pieces. And that means that verification validation is happening for each one of these. And so that's one of the problems with the V model, is that this doesn't really come across. And then once everything has been integrated together, when we're doing system validation, system of interest verification validation, especially the validation, is we're really looking at this integrated system, taking a holistic view, and the basic tenets of system engineering, where we are assessing the behavior of the system. Behavior of the system is a function of the interactions of the parts, and also a function of how the system of interest interacts with its operating environment and other systems. And so system validation's a lot more that we're doing. So in answering this question, we're really not addressing the V model per se. We talk about it, but we're more based on the technical lifecycle processes as designed in 15288. Does anyone else have anything you'd like to add about other iterative or sequential lifecycle approaches, outside of what's in 15288? Anybody? Okay, so the next question is, considering the needs, requirements, verification, validation, lifecycle manual, as a system of interest, what process did we follow to deliver it? Did we use the described processes to curate this as a product? I would say the answer is yes. When we did the TPP, we defined what the problem was, what the reason for the products were that we're developing. We identified stakeholders. We went through the elicitation process of getting inputs from various stakeholders. We had a lot of good papers that touched on different areas that were sources of all of our products. We went through the doctrine of what I call successive refinement. The terminology is different, but this is covered in the manual. We did come up with a preliminary set of lifecycle concepts. In that case, we came up with a preliminary outline of the products. And originally, we were going to have two products. One was going to be a guide to requirements, definition, and management. The other was going to be a guide to V&V. When we started working on those two guides, there was a lot of details in them that went beyond maybe what people would expect in a guide. In a basic guide or set of guidelines, people are envisioning probably no more than 100 pages or so. And so both of those original documents kind of outgrew that kind of a goal, but we didn't want to lose that detailed information. So we decided to combine those two into what was called the Needs and Requirements Lifecycle Manual. Since then, we've added the V&V in there. So the Needs, Requirements, Verification, Validation Lifecycle Manual evolved out of that. And the title is very descriptive. It talks about the development needs, requirements, the concepts of verification, validation across the lifecycle. But we still felt there was a need for shorter versions of guides. And so we have the guide for needs and requirements and a guide to V&V. And the guide to needs and requirements covers a condensed version of generally what's in the first half of the manual, and verification validation covers basically what's in the second half of the manual. However, because verification validation is activities that occur all the way across the life cycle, there's going to be some overlap in that we do verification validation of the needs and requirements. So that's covered in that guide, but yet planning ahead for system verification validation, planning ahead for design verification validation starts when you start doing your lifecycle concepts. Some people call your early verification validation activities. There's going to be some overlap of the two guides, but they're going to be kind of a summary. Their outlines evolved. We had original outlines, and so we decided to update those as the documents matured. Anyone have any comments or questions on the evolution of the manual and the guides?
Lou, this is John. I got a question on the chart here. Why did you spiral inward instead of outward? Like the spiral model doesn't end at the center. It keeps going around and around. This kind of implies that you're ending at the center and there's nowhere to go from there.
The spiral development as a product development process is different than the doctrine of successive refinement. The doctrine of successive refinement is something I got out of NASA's System Engineering Handbook several iterations ago. I wrote some papers on it also. It says we start with the big picture and then we zero in on the solution. And so it's not meant to be the spiral model. The spiral model is a similar concept developed by Barry Beam. They look similar, but this is just zeroing in on the solution.
Well, where do you go after you've zeroed in at the center of this spiral? That's an initial architecture. You're not done yet.
No.
Where do you go from here? Yeah. Where do you go from here?
From here, this diagram shows up in the design verification validation section of the manual, where we start now with our needs and requirements and preliminary architecture, and then we go through design iterations. The output of that is the actual physical architecture or design output specifications that we can build to our mature lifecycle concepts, our mature models, plans, schedules. The output of this would be occurring probably at a CDR, whereas the output of the other one would have been like at a scope review or mission concept review. Does that answer your question?
Yeah, pretty much. That's, if at the center of the spiral, you're saying you've got a baseline physical architecture. At this point, you go ahead and fabricate code and train the elements.
Yes. So we make a difference between architecture and design. Design is a realization of the requirements in the architecture as defined in the System Engineering Handbook. The actual design concept of moving into the actual physical implementation, it's going to take several iterations, and that's what this reflects. And then eventually we're going to zero in on a solution that we're going to actually go build or code.
Okay.
It's a little bit different way of looking at it. It's not the spiral model. It's a different concept.
Okay, thanks.
Any other comments, questions?
There are some emerging approaches based on property-based development, though. I was wondering
Okay.
how they intersect. When we look at functional intent, we have certain invariants that we need that we want to discharge in the context of our operational scenarios and environmental conditions. So a model-driven approach, we look for certain properties to be discharged. And as we go into architecture, we need certain availability and integrity type constraints where we have architectural intent and we look at those properties to be discharged by the next level of refinement. Is there any sort of property preservation type context in this work, as in what we're trying to maintain? We look at the functional intent, the behavior is what we're doing, but what we're doing it for is to preserve certain attributes or concerns at the higher level. I was wondering, have these two threads intersected yet?
I think conceptually they do, although I just don't use the same terminology that you're using. In general, the manual is focused on needs and requirements and verification validation across the life cycles. There's other life cycle processes like architecture that the manual does not cover. It mentions it and says that we're doing this concurrently. I talk about the flow down of requirements from one level to another, the concept of allocation, budgeting, traceability, but I don't get into any of the real details of architecture. That could take a whole new guide just on architecting. So, we'll leave that up to the architectural working group. We do definitely have to realize that architecture and requirements definition are two concurrent processes, and that's part of the iterative recursive nature of system engineering is those two things cannot be separated in my mind. Any other questions? These next 5 questions, I'm going to be going back and forth between a diagram and these questions. So the first one says, do you set it up with the customer so that you can take credit for validation at such an early stage? Or for instance, do you continuously validate that can only say that requirement X is valid when the product is fielded? From a terminology standpoint, I have a few issues with this in that, as I point out in the manual, the word validation verification taken by themselves is ambiguous because you don't understand the context of what they're talking about. For instance, what is the thing being validated and against what? And that's not really clear here. So when they say, does the customer take credit for validation at such an early stage? It sounds like they're saying, can you take credit for system validation early in the life cycle rather than having to wait until the end? It's not clear what they're talking about in that case. And continuous validation, yes. But say a requirement X is valid when the product is fielded, no, not the approach that's in the manual. And the manual actually have this broken into 2 different diagrams. So I wanted to show how everything fits together. Starting at the left, we have the business submission analysis, stakeholder needs, requirements definition processes that take place. And we're gathering a whole lot of different information. That all feeds into a set of lifecycle concepts, which feeds into the needs. The needs themselves are verified and validated. Then they're transformed into design input requirements, and they're transformed into design and output specifications, transformed into our realized system of interest. On the top is all the validation activities. In answering the question, from a requirement standpoint, the requirements are going to be validated against the needs from which they were transformed, and the needs are validated against the lifecycle concepts, the work that was done, as well as validated against all this stuff on the left side. Do the needs communicate correctly, consistently, completely what the stakeholders need the system to do? If you've defined the needs, then everything else from the right of the needs is validating a set of needs. And on the bottom is the verification activities, and there's different kinds. Starting at the right, the verification of the system itself, there's production verification against the design output specs. Was it built to print, built to drawing? As well as verified against the design input requirements. Did we meet all those design input requirements? The design output specs, which is the outcome of our architectural design definition processes, those have to be verified and validated as well. And our design input requirements are verified and validated. On the bottom, the orange boxes are organizational set of guidelines, lessons learned, requirements that the organizations have defined for how you're going to do system engineering. Going to the left, our lifecycle concepts are going to be verified that they were developed per the organization's requirements for defining lifecycle concepts. And those concepts drive how the team does those activities. The needs, the same thing. There's going to be an organizational requirements for the needs. Now, the INCOSE guide for writing requirements is really the INCOSE guide for writing needs and requirements. In version 3 that came out, we treat needs and requirements both in the guide. And we have characteristics for individual needs and sets of needs, as well as individual requirements and sets of requirements. And there's rules for meeting those characteristics. So that would be a verification activity of those, because those are the requirements for writing good needs or requirements for writing good requirements. How we do architecture and design, the organization is going to have their own processes for how they do that. And so you're going to verify that you followed the processes and all the standards. And when the system of interest is going to be built, realized, manufactured per the quality standards and defined by organization, how do you build and code something? But then the validation occurs continuously. So we're always doing validation of some type. It's not just the right side of the V. Let me go back. As far as the manual is concerned, we didn't capture anything in the manual in a tool as a system of interest. We have the list of inputs, we have the comments that people have given us, and so on, but none of this was captured in a tool. Now, if you're talking about an actual system that's being developed per the needs and requirements verification lifecycle manual, then at the basic level, from a needs and requirements standpoint, we need a tool that allows us to capture all of those inputs. We need a tool that allows us to model this diagram. So we need a tool that allows us to capture everything on the left, capture our lifecycle concepts, traceability between the lifecycle concepts and this information. The tool needs to allow us to do that. The needs are going to have traceability back to their sources. And so that's going to be also a verification activity to make sure you have the proper traceability. And then the traceability enables us to do the validation. So that needs to be done in the tool. The transformation of the needs into the requirements needs to be captured within the tool. So we have traceability, bidirectional traceability between the needs and the requirements, and also between the requirements and not only their parent needs, but any allocated requirements or any other sources that the requirements were derived from. And the same is true through our design activities and our system verification validation activities. So we need a tool that allows us to capture the data and information, create a data and information model of our system of interest and of our processes and all of our artifacts. And so we don't want just a requirements management tool. We want a tool that allows us to capture all this information, including needs and requirements. And the big thing is the traceability and a tool that allows collaboration, because you have different people working on different artifacts that are represented by the data information model. Good question. Question 8, how are the concept of needs verified? As stated in 15288, first verification is to provide objective evidence. And so I kind of covered this. The lifecycle concepts are really going to be verified against the organizational's requirements for defining how you do the concepts. And so verification in this sense is really against the requirements for doing the activity. What's really important besides that is really the validation activity. Does this lifecycle concepts represent a system that will meet the expectations of our stakeholders within the constraints that we defined in the left, and the integrated set of needs, validating, do they actually communicate the intent of all the sources that they were derived from? Anyone have any comments on that?
Yeah, Lou, John here. Get back to the chart, please. My understanding is that needs are validated and requirements are verified, requirements being shall statements. So I don't understand how needs can be verified. You can understand that you want to verify the organizational requirements for defining those needs, but not the needs themselves. There's no shall statement associated with the needs.
And I'm glad you mentioned that, because it's definitely true. One of the big hurdles that we're trying to overcome is the use of the term requirements verification when really is meant system verification, and needs validation, which is really meant by system validation. In the manual, we define that there's requirement verification, there's design verification, and there's system verification. All three are different concepts, and they're all being verified against something different. So when you hear requirements verification matrix, in the manual, we don't use that. We use system verification matrix, because that's really what's intended. We're verifying the system meets its requirements, or validating the system against the needs. To be accurate in terminology, those are system verification, system validation. And so when we talk about validating or verifying the needs, we're really talking about the needs themselves, not that the system meets the needs. We're talking about validating the needs, communicate with the intents from their sources, and verifying the needs were constructed per the requirements for defining needs. That's one of the big hurdles that we're having, is gotten ingrained that requirements verification is what really they mean system verification. And so throughout the manual, when we say requirements verification, we really mean verifying the requirements, not the system. Or the design verification is verifying the design, not the system. And so that's why this chart is kind of a Rosetta Stone, it puts in context all the different uses of the word verification and validation.
Thanks, but that's kind of a different definition of verification and validation that I'm used to. Yeah, you do verify and validate the system at the conclusion of the system development, yes. But the way you validate the system, you ask the question, does the system meet the user need? Yes or no?
Yes.
And then the way you verify the system, you say, well, does the system meet the system requirements, the shell statement? And that's the difference. Now, you can validate the user needs up front. You can say, well, is this user need valid? Yes or no? Okay, and that should be done up front, as you have on the top of the chart. But I don't understand needs verification. I guess I'm missing the point. You have a set of needs that you can validate. I agree. But the needs don't contain any shell statements like a requirement does. Needs are verb noun pairs, stop car, so forth, those kind of needs. So I can understand verifying the organizational requirements for defining the needs, but I lose it when I think of needs verification because there's no shell statement and it's not a requirement. So you're going to confuse people.
We have that debate back and forth. In general, an organization is going to have requirements on their people. And by requirements, they're going to say, you shall develop requirements that have the characteristics in the guide for writing requirements. Now, the guide for writing requirements doesn't have any shell statements in it as far as the characteristics and the rules. You're right. But the organization shell statement is that you're going to develop your needs and requirements per the guide for writing requirements. And so that's an organizational shell statement, an expectation of management that all the requirements are going to be constructed per the characteristics and rules in there. And so that shell statement is levied on the organization. And so all these orange boxes in the bottom, the organization has defined, this is how we're going to do things. Project teams, you shall follow those requirements and guidelines. Even if they don't have a shell statement in them, we're giving you a shell statement. You have to follow that. When we've baselined a set of needs, we're going to verify that they have the characteristics defined in like the guide for writing requirements, and they follow the rules that were in the guide for writing requirements.
I guess I'm having heartburn with the word needs verification. I can understand needs verification being changed to organizational requirements verification. I can understand that. And then you perform that organizational requirements verification in that box. I guess output of that would, the system needs definition based on the requirements of the organization. But I don't understand needs verification because there's no shell statement.
It is important to understand, everybody, that V&V has never required it to be a shell statement. There is no such thing. V&V means, did we do the right thing and did we do the thing right? It never has. No document says that V&V requires a shall statement. So, for example, needs elicitation. Did we elicit the needs right? And did we elicit the right needs? That is the bottom line definition of V&V. Did we create the right architecture? Did we create the architecture right? Did we get the right design? And did we get the right design the right way? Did we design the system correctly? Did we design the correct system? Did we build the right system? Did we build the system right? All of those are V&V. It doesn't require any shall statement at all. It's just a matter of do. Did you do the right thing? Did you do it right? And that's really all that needs to be taken into consideration to get over any hurdle or any constraint that somebody might have that you can't have V&V without a shall statement. That never was the case. It's do the right thing and do the thing right. That's all V&V requires.
Well, thanks. I understand right system and system right. But the way you prove that the system is right is using shell statements and verifying that the system meets the shell statement. That's how you do it.
Along all the while, all the life cycle, you measure. When you measure something, you measure, was it done right? Was it done the right way? And was it the right thing that was done? You simply need measurements to have validation and verification. You don't need to restrict it to something like a shell statement. You just need to be able to measure it to determine verification and validation. And throughout the life cycle, we all know there are myriad ways of measuring everything we do. And because we can measure everything we do, we can measure, did we do the right thing and did we do it right? It doesn't require a shall statement, just the measurement of do or did not.
Well, the do it right is part of the shall statement performance requirement. So did it do the right thing? What you're measuring is the performance of the system, which is a part of the shall statement.
That's at the full system level, which, as we all know now, if you any time wait until you have the full system to do V&V which nobody does anymore because that lesson was learned a long time ago. That's the worst time to do verification and validation, because now we have the ability to measure anytime we want during the entire life cycle. We no longer have to worry about V&V. We do something, we measure it, and we determine done right, done the right way, and the right thing. And we can do that whenever we want to. We no longer should and no longer do wait for V&V on the entire system. Everyone knows that's a recipe for disaster.
Right. Yeah. You do it as you go along, not wait until the end. Right. But you're not measuring. What you're doing is the 4 methods of verification and validation: demonstration, analysis, test, and inspection. And maybe comparison would be a 5th one with another system. Those can be measurements. The testing is the measurement, but the demonstration, analysis, and inspection are not measurements. Just using the word measurement is not good enough.
And the needs verification, lifecycle concept verification, the requirements verification is defined in here is basically an inspection activity against the organizational requirements for defining requirements. Even though the standards and guides may or may not contain a shell statement, from an organizational standpoint, there is a shell statement implied that the project team is going to follow those requirements. That part of it is, you have to accept that it's not exactly the same as the classical definition of system verification. And system verification and validation is exactly what you state. It's against the requirements. The convention that we all grew up with is that those requirements, so we know they actually are requirements, contain the word shall, in the context that the shell is an icon that says this statement is binding and we're going to verify it's met. And so by convention, we use shell statements in the design input requirements. But when it comes to the needs and lifecycle concepts, the concept of needs verification validation has always been something that we did with like a system requirements review. What are you really doing when you're verifying your requirements? So I have a system requirements review. One thing I'm going to look at, are the requirement statements constructed properly? Are they well-formed requirements? That's what we're defining as verification. And then validation is, do they communicate the right thing? Do they communicate the intent of the needs from which they were transformed? We've always been doing it this way. This diagram is kind of like a model of the overall process. I could change the words, but then someone else would find a problem with that. So this is kind of a compromise to get across the fact that we really are doing a validation verification activity of our requirements against some standards and our needs against some standards and lifecycle concepts against some standards, even if they may not individually contain a shell statement.
Well, let me close out by saying I could understand the word needs verification was changed to organizational requirements verification, and lifecycle concept verification was changed to organizational requirements, lifecycle concepts verification. You can verify requirement. That's what you're doing in the bottom 2 boxes. You can't verify needs.
The requirements verification here is no different than the needs verification.
Needs are not requirements. Needs are functions.
No, but the requirements verification that I'm showing in the middle here, that's against the same kind of set of standards as the needs verifications against. Only it's the organizational requirements for defining needs, and the others are organizational requirements for defining requirements. We'll have to table this so we can move on.
I think it's confusing to define these terms this way.
Well, let me put in my vote for whomever else. I don't find it the least bit confusing. I think it's just fine. As long as you look at it as do the right thing and do the thing right, it doesn't make any difference what parochial or past or legacy definitions of V&V exist. Current and modern understand completely the idea of verification and validation if you're doing the right thing and doing the thing right. So we don't need, it doesn't preclude or eliminate any legacy definition of V&V that anybody wants to use. They can, of course, continue to use that. But the new, current, and modern idea of verification and validation, as you've shown it here, is perfectly good and perfectly understandable as far as I'm concerned.
Where's that definition of the current needs and requirements verification and validation? What standard are you using?
I'm using the standard definition of 15288.
I didn't respond to that question because it's not necessary. When you do engineering analysis or whatever, standard definitions can be definitions that are used by most people. They don't necessarily have to be from Oxford, Cambridge, IEEE, ISO, AEC, or anyone else. It's just a standard accepted definition.
Well, we need to define the standard, and that organization needs to define its own definition of terminology during the system engineering process as part of the process.
No customer no adopter, early adopter, no stakeholder is going to be held to that. You're never going to get anywhere in the needs elicitation if the first thing you do is only approach a person with a problem with a standards-based approach. If you haven't learned that lesson by now, you're going to learn it very quickly.
I'm talking about standard definitions.
Stakeholders have their basic standard definitions that they use, and it's our responsibility to not put away the standards that we use, but to extend ourselves into a stakeholder-centric environment, which may have standard definitions and usable definitions and actionable definitions and consensus definitions that are not necessarily tied to any IEEE or ISO standard that we may use once we get to doing our work.
INCOSE, and we use INCOSE's definitions in the SE's handbook, and they use 5288. Okay, and the organization needs to define upfront what terminology they're going to use so that everybody can communicate on the same wavelength. And this thing is confusing.
Not the least bit.
We've gotten tremendous feedback about how valuable this diagram is. A version of this is going to be included in the new System Engineering Handbook, not the left side of it, but the right side of it. So I think we just have to agree that we have a difference in opinion. I tend to deal with stakeholders that deal across a whole bunch of different domains. There's a lot of people in INCOSE quote to me what CMMI defines or what IIBA defines, the Babcock they're talking about or whatever. And even though we're an INCOSE organization, there was the paper that was submitted in IS. It was really good. It was by the software working group. They basically said that if INCOSE is going to remain relevant to all of the different people that develop products, then they're going to have to adopt a little bit. And from a standard standpoint, there are probably 5 or 6 different international standards for needs and requirements and for product development. And I say whenever there's multiple standards, there is no standard. So we get to pick whatever standard we want. In the manual in the front, I talk about a whole lot of ambiguity that exists in 15288 and in other cases, a particular ontology that is used in the manual to try to resolve a lot of that ambiguity.
Well, you're introducing more ambiguity here. So end of topic. Let's move on. 5 o'clock.
We didn't get very far in our questions.
Lou, Francesco here. Can I comment briefly on this, please?
Yes.
Yeah, because I think this is a very important topic. I attend similar discussions in other working groups, and I think it should be clarified. I have an opinion which is very similar to Mike's opinion in a sense that there are key terms like validation, verification, but also life cycle, requirements, risk that always need to be contextualized. As you said at the beginning, we don't need to take any standard in the sense that if we use a dictionary and we use the Latin etymology of those terms, we can clearly understand that we can verify a system, we can verify a requirement, we can verify whatever we want. It is inside that terms, the intrinsic meaning. What is really important is to every time specify the context of those terms, because if we talk to a systems engineer, and we talk about verification, he thinks about system verification, he thinks about system lifecycle, but if you talk to a project manager, he has a different view. He thinks about project lifecycle, okay? Project requirements, not system requirements. And this creates conflicts, misunderstandings. If you talk to a business analyst, for instance, he's thinking about business requirements. So it is extremely important if we want to expand our and improve our communication with other communities and all stakeholders, to always clarify the context of each term. And I think this diagram goes in that direction. Maybe we can discuss some terms, we can improve the terminology, but I think, as Lulu said at the beginning, the main goal is to specify that we can verify a design, we can verify the requirement, we can verify the system, and he tried to contextualize this. So I really appreciated what Mike said before.
Well, thank you. There's no perfect way of documenting things. This is a compromise from a whole lot of comments that we've gotten. I'd say 99% of the people just love this diagram because it does make really clear the context and the use of the terms. And the ambiguity is when people use verification validation generically without specifying context. In that regard, this really clarifies the context, and that's what its real purpose is.
If I understand what you're saying, because it is a different type, got a different background, and so I had a similar question to what I understood your contextual observation around it. What you're really doing is saying that the needs are sufficient for purpose for downstream activity. You're looking at it from organizational standards, assessment criteria, that when they've documented their needs set, there's a minimal adequacy criteria for that to be sufficient for purpose downstream. And you're verifying, if I understand it, in that loop going back in your loop here, the adequacy of the integrated needs set to do the lifting downstream.
Very well stated.
Okay. There may be the verification word is kind of like as you know, it's a targeted word, but there may be some words we can look there as regards establishing adequacy, or maybe another way to get out of this hard V&V type dialogue. It's just that I read your paper here, and the paper in some ways helped out a lot because it had some more context to what you're doing. And it's the missing context that I think got us into trouble here when you see the diagram without the context.
True. Every term in here is defined in the manual. There's a definition for everything in red here in the manual.
I don't know, Louis, if you would agree on, I see this, we use it a little bit as a kind of a life cycle approach. I mean, you can talk about the life cycle approach in the context of the V diagram, but also in the context of this, it's a little bit like a horizontal V actually, but with more kind of granularity. So I don't know if you agree on that. This is getting close to a kind of life cycle approach description.
I'm not sure. What was your question?
What I'm saying is that you can use the V diagram to illustrate your kind of life, or that's a life cycle approach, right? But I think this diagram also is kind of a life cycle approach where you see the different transformation happening and the verification validation. So what I'm saying is that I think this is very efficient in explaining the steps, and we use it a little bit as sometimes a substitute to the V diagram. Instead of showing the V diagram, we look at this one instead.
This diagram applies to every box in here. We have concept, needs, and requirements for everything. That diagram of showing the different kinds of verification, validation, and context applies to every one of these. That's one problem with the V model, is it doesn't really make that clear in the complexity that we have in doing systems engineering.
It may be where you want to look at compositional argumentation, and that's where under PMM, the property model methods, they talk about property preservation. But as you come down through your decomposition, you're really constraining the space below you, and therefore the ideal thing is you can build in isolation, but if you meet your compositional spec, your obligations, you can seamlessly integrate and provide the adequate value to the level above. And it may be worth looking at that diagram where you have your system elements, Lou. Understand what is the contractual flow down and how do we maintain that in a model-based approach such that we do have a compositional guarantee that we're efficiently closed relative to spec. Because I think that's what you're implying here, but your other diagram, you might be able to annotate the diagram to show. I think under the PMM method, he calls it the prime contract theorem, that says the level below has to be sufficiently constrained or minimally constrained to meet the requirements of the level above. And we try and do that mathematically if possible, so we end up with a compositional proof at the end.
Okay, we're past our time. So next month, we'll continue discussing these questions. Hopefully we'll get a good dialogue like we did this time, sharing of ideas. Everyone looks at things maybe slightly differently, and that's fine. That's how we were brought up. Some of the things we were brought up in applied really well to systems developed in the 20th century, and some of the things that we need to do a little bit differently for more complex software-centric systems in the future. And that's one of the things that we're trying to do in developing the manual. We'll go ahead and stop the recording. We'll put this on the website so people can go back and listen to it if they want to. So I thank you all for attending. Is there any other closing comments?
Thank you, Lou.
Maybe one question I have is I'm trying to get to the Yammer. I can't seem to figure that out. I don't know if there's a guide or something.
To get to Yammer, you first have to be able to log into the INCOSE Teams. Make sure that works.
Okay.
Then you'll be able to go into Yammer. I tried going into Yammer directly like you did, and it just didn't want to work. But as soon as I was able to log in, have an active password and everything working fine, and then I closed Teams completely, relogged in, and then I went over to the three dots and I selected Yammer, and then it worked.
So maybe what I don't get there is, so the Teams is different from the Connect.
The Connect site has nothing to do with Teams. The INCOSE version of Microsoft Teams is what, when they sent you that email and it said first name dot last name at incose.net, that is your username for Teams.
I think that's the email I tried to find, but I can't find anything from INCOSE.
They send an email out with your Teams username and then ability to set a password. But you got to do that first, then quit Teams, come back in before you can set up Yammer. If you're on your laptop, there is no separate Yammer app that I know of that you can just load. There is on an iPhone or an iPad, there's a Yammer app, and that Yammer app you can log into using your Teams login, but you got to establish the Teams login first.
Okay, actually now I found it. I searched for Yammer, but if I search for Teams in my emails, then I found it. Okay, gotcha. Now I think I will be able to figure it out. Thank you.
If you have any problems, send me an email directly at wheatonconsulting@gmail.com. I'll help you walk through, because I had some problems getting it to work originally too, and I think a lot of people do.
Thank you. Yeah, I think the issue I had was I was trying to find that with searching for Yammer, but I should have searched for Teams. Okay, thanks.
So let's go ahead and end the session.